And those who don't know me, I am Vasat Sagan. I am the Deputy Director of the Taylor Geospatial Institute, leading research, consortium engagement, and computing and sensing and those types of work. So, and today's workshop, really, my goal here is to communicate what TGI is thinking in terms of its investment priorities in computing, data collection, platforms, and facilities, and really get to know your thoughts, your projects, how this would be helpful to enable, empower you to great work, collect unique data sets, and go after big opportunities, right? How this is going to be helpful. I also want to know, like, and if there's opportunities you think we are not capturing to utilize this platform and sharing those resources and information. That's kind of my overall goal for this workshop. And also, I would like this to be very informal. You see, I don't have my ties today. And ask questions anytime, stop me for any comments, suggestions, and that's really goal to understand what's the potential and what are the opportunities out there and how you utilize or how this benefit your research, right? And questions like that. So next slide. And so several things we want to talk about. I would like to just very briefly remind us our vision and mission and why this aircraft, crewed aircraft data collection platform, what I think is important, and how this helps to advance TGI's vision and mission, and then propose sensors and sample projects that has been done out there using manned aircraft that can be done with us in this consortium, and then other opportunities. And those are what I would like to talk about today. So let me see, our vision, right, for advancing too quick. So TGI's mission and vision. Our mission is to advance geospatial science through multi-institutional, interdisciplinary collaborations in order to create innovative real-world solutions to grand societal challenges. And keywords there, multi-institutions, that's us, the consortium, interdisciplinary across various fields, right? Those are the keywords in our mission. And then our vision is to be the nation's lead, I have to be very precise on this, leader in geospatial science research and accelerate the St. Louis region's development as a global geospatial center of excellence. And we are a consortium of 8 outstanding Midwest research institutions, 7 universities, and an independent center, which is Danforth Plant Science Center. So the vision for research infrastructure, right? And TGI, one of the ways we think is best for this consortium that enables, empowers our researchers is to help with collect unique data sets, right? And if you look around the geospatial ecosystem today, companies, industries who are thriving, doing 2 things. One, providing unique data sets. Think about Planet, think about Maxar, Stellogic, and Pixel, and right, all of those companies are providing, selling very unique data sets, and that's their business model, right? On the other hand, if you look at many other companies like Geospark, right, and Descartes Labs, and many others, just name a few, right? And those companies are thriving, and their business model is to provide analytics and utilizing all data sets, kind of providing unique analytics to their customers. And TGI has real opportunity to be the leader in both. We don't have our satellites, we don't have this, that, but, and and utilizing various sources of data, partnering with industry who provide data sets, then we can provide those to our researchers. And plus analytics we can provide, right? And also in terms of unique data for us, like a capability with manned aircraft, unique sensors, which is beyond the capability of any individual researcher can get or purchase, because it's money, it's about multiple people maintaining it, right? And then that annual cost that comes with it. So I can do as a faculty that may or support maintain that facility, right? So that's where TGI can come in and then provide us create this unique resources. And you may have heard this a lot from me or others. And often researchers spend 70–80% of our time, your time, on collecting data, and 20% on actual analytics, right? And that's an opportunity for TGI actually, if we help us collecting that data sets or curate, and that advances your research, right? And that's from our view that that could be very impactful. So how we are doing this data computing analytics? We are partnering with companies. Planet is one example, and we are exploring many other companies with variety of data sets and figuring out the way that make those data sets available for you. And that's a work in progress, right? And then partnering with government. We have been having conversations with NGA, ODNI about TGI being a data broker for them and make those data sets available for our researchers. And computing, as you know, we have 3 computing facilities established so far. One funded from NSF. We are establishing it at UIUC. And several of us got that grant from NSF. Second, we got another grant to SLU and to TGI. We are creating that computing facilities here at SLU. And then TGI has also invested about $600K to create 3rd cluster. So we have 3 computing clusters today, which will be launching in January. Opportunities, how you can access, and this that we are creating pipelines, creating documentation, how you use those computing facilities, right? And also we are working on cloud computing, and that will be available for researchers. That's the kind of our vision for data analytics in a nutshell. And also we are working on data services request form, which is available online. You can request data, you can request analytics services. But we are making a major announcements in January, February timeframe with deadlines to how you can access, how you can request those resources. Why crew? Any questions so far? And the rest of the slide is a quick, fast, hopefully. John, Bob, how I am doing?
You're doing great, Basit. Keep it up.
Yeah,
Great.
keep going.
Okay, move on. So why crewed aircraft, right? And then a number of things, many examples there, right? Drones can only cover small areas, 5 acre, 10 acre. And then satellites far up in the sky, hundreds of miles away. And then the resolution is often very coarse. It's great for many applications, but when you look at more high resolution issues, right? Let's say a plot level phenotyping, 10 feet by 10 feet. I mean, this year we got Planet, Maxar, and looked at pixel imagery. We tasked pixel satellites, our Bradford. And you can see even a field, like an acre field under satellite imagery, and which is not helpful to address some hypothesis-driven research questions. Think about flooding, disaster mitigation, or rescue. And drones can only cover a few acres, but you have to fly over large areas, you know, a whole valley or a floodplain, right? And then and our researchers request data collection, our North Carolina, California, our rangelanders, pasture forest areas, very large areas, and satellite, the resolution is not there, and then the best way to do as manned aircraft, right? And then digital twin, everybody is talking about digital twin, and drones we can't cover, and even small area to cover in an urban environment, very challenging, and FAA limitations, flying over populated areas that does not allow us to do the type of work at scale, right? And then another really important piece there is that we often build models with sensors, data we can see, we can touch, we can control, how do we collect, before we can scale that to global studies with satellite imagery. And that's where the manned aircrafts can be very unique, provide the data sets where we want, how we want, and we can build models and calibrate for satellite imagery. So this is why this is a very unique area. And then the sensors we are putting on this is very cool, that and very unique, that in the context of dozens of hyperspectral satellites launched this year, will be launched next year, constellation of hyperspectral satellites, right? And then again, resolution, the scale impact, and how do we address those? And that's where I see the value of this manned aircraft system. And then a wider area, FAA regulations and safer flights and this, that, right? And this, again, what I mentioned, a number of areas like many projects can benefit from this: flood mapping, digital twins, population density, disaster response, crop phenotyping, right? Many projects that drones are very limited in. And then the other pieces that we are looking at, those are very high-end DoD grade, Department of Defense grade hyperspectral cameras and systems, which means better signal, really crisp spectral features that are critical when you map some rare phenomena or do cutting edge research, really. And drone sensors, it's small. To make it small, you have to compromise the quality, signal, many other things, right? And then for satellites, we talked about the limitation. So that's what we are looking at, like very high resolution RGB, linear, severe hyperspectral cameras, and then very cool infra thermal cameras. And there's a term called cool thermal, cool severe cameras. What does it do? It has an internal cooling system like a refrigerator, if you will say, and that cools all detectors, so that allows us to collect more high resolution data. And we can't have a cooler on a drone-based systems. It's not just possible. So that's why what's different, what makes us very unique here. And then the lidar system as well, really cool. That's the kind of equipment we are putting together. I don't want to go through this. We'll share this list of projects with you, how you can apply those and what type of projects. You can see from snow depths to urban heat island, water quality, forestry, archaeology, landmines, to many other applications we can do with this. Just few examples of research that can be enabled. First one is I have here archaeological projects and flying over Cahokia, for example, and detecting underground objects with lidar hyperspectral, detecting what's in plants, the chemicals, the iron or calcium, magnesium that's related to archaeological remnants, right? That's a type of creative, innovative work we can do beyond just visible cameras or sensors in archaeology. And then forestry projects, flying over a large area, of course, tree species mapping, tree house mapping, where trees fall or power lines or not. Would that cause any power outages, predicting power outages in terms of in the storm events, and can be very interesting research, right, enabled by this platform. And carbon sequestration estimation, and forests biggest source of carbon sink. And then we can fly over the coasts of Florida, even Hawaii, or and anywhere in the country, or even internationally, we can fly with manned aircraft. So do large area research. And this is another example of that you can get data at the individual tree species, which is not possible with satellite imagery. Entire forest park, maybe just green or this, that, right? But with this, you can get individual tree species, but at the same time, you can cover a very large area. That's not possible with drones as well. 1 hour, we can cover entire St. Louis metro area with flights, right? That's the kind of scale, and we are looking at. For just St. Louis University campus, we have, it takes 1 day, maybe 10, 20 flights or multiple days with drones. So it's that's the type of scale we are looking at. Forest fires, another example, and then digital twin and heat loss mapping. This is actually another use case done by those cameras in Canada somewhere. And basically a digital twin of entire cities produced, and they were able to create a single home level heat loss or energy loss, right? And with digital twin and this, that, and that's the level of research can be enabled. And then environmental applications like environmental pollution, water quality issues, algae bloom predictions, you can name it. And coral reef mapping, as I said, we can fly over Florida and look at coastal resilience issues. We can go to California to look at water quality and impact of wildfires on water quality issues in the lakes. And that's the type of research. And then, yeah, those are the examples of water quality projects done, our lakes, rivers, our many places, right? And mapping wetland ecosystems. Agriculture projects, as I mentioned, large area, plot level monitoring, crop phenotyping without FAA restrictions. You can fly, you can collect data sets at scale. And then geological projects. This was done in Nevada, I believe, with the similar sensors here, mapping quartz, rare earth minerals, and number of energy resources. Another example of rare earth mapping. And then gas detection, like methane detection, and other types of greenhouse gas emissions can be mapped with hyperspectral infrared cameras. Really high end, that makes a difference when you compare this with drone-based systems. Another example of methane detection and oil gas seepage anomalies, and done at scale. And you need that scale and that level of data sets with the same camera, same sensors, whatever matters, the areas where we see oil spillage, our bedrocks and areas. Health projects, and when you have like air quality data, our urban areas and population density, settlement trees, and you can combine those to make a good story of air quality and health. Type of research. And then disaster response, again, during earthquakes or flooding, and you need to really look at large area, and satellites are too coarse, and that's where the manned aircraft can be very helpful. And disaster response, again, flooding, mapping flooding, rescue operations, and this, that. And maybe the last point I mentioned a number of times, how this fills a critical gap between drone monitoring with satellite monitoring, right? There's resolution issues and the scale issues we can quantify with drone and manned aircraft and satellite data sets. So our algorithms can be robust, can be global.
Can I ask some questions, Wasit?
Sure.
Oh, thank you. So I have a couple of questions. First is that you're talking about the area coverage by manned aircraft versus the drone imagery. So what is the typical swath difference between the imagery taken by the manned aircraft versus the drone imagery? And second one is that how you usually post-process the data. Like I have heard like there are some systems that can post-process on the fly, but there are some systems that need, collection first and then post-processing in the lab.
A great question, Adil. Appreciate that. With drones, and really the altitude determines the path, right?
Yeah.
The swaths with us. And with drones, we are talking about ideally, and maybe a 10, 15 meter or 30-meter maximum swaths in a flight path. If you fly at 400 feet altitude. With this, we are flying at 5,000 feet altitude. And then average, right? That gives us maybe a kilometer wide swaths of data collection. So in terms of area, and really the height determines that. In terms of processing, I know we have been using edge computing on a number of applications. We are developing fully automated drones on the edge, on the field, and this, that. But this level of data sets processing, it has to be done either on the cloud or on some high power computing systems, not on the edge.
Got it. Thank you.
Any other questions?
Do these units have to be attached to or permanently attached to aircraft, or can you move those units between aircraft? Are we talking about a dedicated aircraft, or are we able to use, for example, some of the aircraft at SLU?
Wonderful question. I love that, Sean. Thank you. So one manned SLU has about 50 some manned aircrafts that are being used for training and programs and flight training, right? And one aircraft was dedicated to SLU, and then which is available to TGI. Fully use it, right? It's available for TGI. So we have the plane, and then also there's a group of faculty in the Department of Aviation Science at SLU who use aircrafts, who teach how to fly commercial flights, right? And then there are two, one pilot, one actually faculty whose research focused on crewed aircraft engineering design, that are being recruited to the Department of Aviation Science at SLU now. So basically, there's two pilots will be available to fly this drone, help us collect data sets. In addition, I know that we have been working with Mark Bookout, for example, from University of Missouri, SNT, Chief Data Scientist. I don't know if he's here. And then we have been talking with him how we can utilize his expertise to help with data collection. And also we are working with a company out of Illinois, and who actually specialize in manned aircraft to, as needed, help with those flying and things like that. I think you asked another question, how. So we are planning to, it's detachable, it can be put another aircraft, but initially we are thinking just one aircraft, fix it, because you have to make a hole at the bottom of the aircraft and certify that with FAA. But folks, my vision on this, if we can show success of one plane, I can see we'll be operating a fleet of manned aircrafts, bigger ones, in next few years, and a fleet, and collecting data from coast to coast. So at that time, we'll have much flexibility.
May I ask a question, Basit?
Sure, Rekha.
So some of these data sets that you intend to provide to researchers, is that service for free, or because my plan is to use some of this, if I can get some initial preliminary data, you can use that to write a grant. Without that, the grant seems sort of very speculative. So is there a way, I'm doing a lot of plant phenotyping. We're interested in urban heat islands. And my thing is all to do with climate change. So
you spot right on. You asked a question. You read my brain. You read my mind. So that's what I'm getting next few slides. The answer is yes and no.
Okay.
So
I'll wait.
I will get to that, right?
Oh, okay, thanks.
So the long term, any other questions before I go address that? No, okay. So this cost of the sensor plane is free, and we'll have operators and people who help with data collection. And then we are planning, if we go forward with this, it's not final decision yet. It depends highly on what this group thinks, right? The sensor package is about 1.5 million, and everything putting together in there, right? And again, I got a $1 million grant, and some of this, and if not all, are also used to create this plane. So that's the plan. And then we are using multiple sources of funding, not just TGI, to build this capacity, right? That's the initial cost, but to long-term sustainability, financial sustainability of this instrument, and number of ways. I actually looking for your ideas, but number of things came to my mind is that go after contract opportunities. For example, USGS has a 3D Nation program, 3D program. Each state has its 3D lidar data collection program. We can bid contracts. We can take advantage of those opportunities. Here I'm just listing a few. And then NASA Center for Climate Simulation, utility infrastructure companies like Ameren. I know I got almost got a $1 million grant from Florida Power. I know what they want to do, and manned aircraft data collection, right? Many other things. And then USDA and other federal programs. Those are some of the opportunities, but also will help you create initial data pilot instead. But ideally, what I would like to know is that if you all, when you submit grant proposals, budget for, if you need those resources, budget for it. I am going to partner with TGI. This money allocates to for TGI service to collect data sets. Believe it or not, even though in the first year, 100% drones, sensors, instruments, and people that provided data collection analytics support to the consortium came from my lab in the first year, 100%. Maybe one full-time person is covered by TGI. But to test this idea, I actually put budget on my grants for TGI, and I paid TGI, to get the service myself. I did that. So, and I know it works. So what I'm hoping is that people come up with ideas. I want to partner with TGI. I pay for the service. I budget on this, and then kind of that's another view, channel to get to sustainability.
Okay, but can I make another comment? So recently, the Department of Natural Resources in Missouri here, they put out a call for some ideas for funding. And this came out of that Inflation Reduction Act that passed, that had a climate change. It was big on climate change, right? That passed sometime earlier this year, I think. So have you looked at that opportunity? Because we put in some ideas that we would like to do. Now, the funding was sort of variable. You could ask for any amount, basically, you wanted. So we haven't heard back yet, though, from the DNR. Yeah.
So I did not, because I think it was for private institute. No, it's for public institutions.
Mm-hmm.
And so I did not put
Okay.
proposal on this, but that's a great question, great suggestion. Nathan Jacobus.
Yes, I joined a little bit late, but I think for me the main question is going to be how this compares to commercial offerings. right? So with there are companies that you can hire to do aerial surveys that have workflows in place and equipment in place. And so then it's not a capital investment, it's just a sort of, you pay by use. And so I think really understanding what the landscape of that looks like and what the TGI thing would look like in the end. I think that's, to me, one of the key questions that I haven't seen addressed yet.
I love that question, Jason. But we have done Nathan, sorry. We have done our homework. So this is what we know, I know. NSF has a NEO program, NEO. You can search, find. So what they have is a manned aircraft with lidar, hyperspectral, and then probably thermal, 3 cameras or something like that. And I have been trying to get their data sets all these years. I have not been able to get one. And one, if it's on their, like, if there's a big project funded by NSF, and then they put budget in that project, and they fly, for example, somewhere in Missouri, you can see online there where their plans for 2024. If it's on the path or nearby, they can collect data for you, but bring their aircraft from California or East Coast to here, like some days, it's hundreds of thousands of dollars in some cases. Jason Knauf, if he's here, Allison Miller, in 2008 or 2009, we submitted a grant to NSF with hyperspectral studies on PICON. I asked for a quote from a JPL or service in California to collect data in Missouri. The quote was $100,000, right? Of course, that was 10 years ago. Now, the other entities we know is Arizona State or University of Arizona has a global carbon or sustainability observatory, Greg Asner. He got a plane, and I heard recently he sold it, but that's another service. I reached out to him, and it was mostly used in Hawaii and this area, and he had no time to collaborate or work with us. And then that's one. The other services in nearby, 2 we know. One, Surdex. Surdex only does business with RGB lidar. No hyperspectral, no thermal, and instead. And then there's Midway Air, another company in Illinois. We hired them as a consultant to stand up this for us. But again, RGB, very low-end FLIR thermal cameras, and occasionally hyperspectral, but it's not at the service level. They haven't doing it. But not at the scale or facilities we have. And that's why we actually collaborating with them. They are integrating our manned aircraft with those sensors because it's advanced and instead. That's all I know, Nathan, and NASA for sure they have, but to bring them to here for our research, we have to pay hundreds of thousands of dollars. Not sure, Jason, Allison, if you are here, if you remember that proposal and that quote, but we didn't get funded that time because just the manned aircraft part is 100,000. That's a lot of money. Any other questions, folks, or suggestion or ideas like, is this a good idea or not a good idea? Or, if this is available to you, would you be willing to put budget on your proposals in the future? Say that TGI has this, I want to utilize this, and in partnering with this, Urun?
Hi, Vasit. Yeah, I think this is a great idea. I was just wondering for some of the work I do, hypothetically say that I budgeted in use of this aircraft, but also say a sensor at the time that I needed. Will there be any in-kind service by TGI to integrate that sensor to the existing sensor pod, or do you envision, since that requires FAA permits, that new sensors will be a no-go?
Happy to talk to you. We are at the very early stage of this developments. Yeah, I'm very happy to talk to you about that.
I was mostly wondering, I mean, as you know, different projects require different types of sensors, which over time evolves. So
Yeah.
do you envision basically a upkeep service where, say that a new sensor needs to be acquired for a future project, will there be technical resources available to integrate it into this plane?
Yes, what I envision is that if we do this well, not just this plane, I'm envisioning maybe a fleet of planes, 4 planes. And then 2, yes, sensors evolve over time, and we can integrate other sensors if we can use that become a public TGI. If we can use that for data collection for others as well, or there's a need for a sensor or camera, and from a group of faculty, we can purchase that. We can put that on the plane. So yes, the short answer is yes, Orhan.
Okay, thank you. And yeah, I mean, just my 2 cents about this project. I think this is going to be quite useful. I do a lot of greenhouse emission gas mapping and prediction, so I think this is going to be great. And you mentioned Greg Asner, whose group was at AGU this year, and they definitely have been making use. Actually, I can share the link to what they have so others can see. They have a similar sensor pod installed on a Dornier, so they have been getting a lot of government grants and even partnering with providing services like that to other universities. So I think us having a system like this would be a game changer.
Thank you. Yeah, I spoke with Greg and his wife, who's at Stanford as well. Yeah, they've been very much maintaining that whole aircraft, millions of dollars of expenses with DoD or government grants. Felix? Raise your hand and then put down your hand. Did I catch you right?
Hello, Bassett. This is Ronaldo Luna.
Hi, Ronaldo.
Hi, I couldn't find the raise hand button, so I guess I just...
That's fine.
Yeah, I have a question. I think this is an incredible capability. I have 2 questions. If we can make this happen with initial investment. I understand you want grants to subsidize some of the sustainable cost. Is this service going to be available to the public, where there's going to be other revenue stream, like other private or public researchers, or just the consortium? That's the first question. And the second question, for a lot of the research that we may do here, particularly the research that's starting to establish correlations, the grant fruiting is it's very important. And I was wondering if you can speak a little bit of what tools are available for grant fruiting, or is that 100% expected to be in the grant by the individual investigator?
To your first question, Ronaldo, yes. So I don't know if you mean by public researchers, if you mean by faculty or people at any general companies or outside customers, companies like that. But the answer is yes. Actually, we want to go after major contract opportunities. Like in Missouri, there's one. called it relates to lidar, right? We go after those opportunities and also work with faculty researchers. In terms of ground the systems, TGI data analytics team have a suite of actually systems ground calibration tools available. Now, yeah, that's available for our researchers, but we need to figure out like the process, and we have a process. We'll be launching, as I said, major announcements in January, February timeframe with a deadline for applying for data collection grants and other services for fees and things like that. So that's available for sure.
Okay, great. I'll look into that, and I guess maybe a different presentation or just stop by.
Thank you. Okay. John, how are we doing in time?
We're doing great on time. We still have plenty of space for Q&A if anybody has any follow-ups or would like to share some more.
I see some questions or yeah, some chat options as well. Okay. So
Basit, I have one more question.
Sure.
So say that we are looking at maybe like a continent scale analysis, large scale analysis, where the plane needs to, land and take off multiple times. I know this is already getting in the weeds, but like say that you're having to pay things like hangar fees, refueling fees, etc., for like a multi-day, multi-week mapping campaigns like the GAO is doing. So is there going to be basically a playbook that you're going to develop or TGI is going to develop for those longer term like multi-flight missions like that, so that we can build it into it, or are there going to be certain costs that are just going to be in kind?
No, we will definitely build a business model around this, and also the type of playbook you mentioned. Yes, we will have a business plan if we do this, move forward with this capabilities.